A couple of quick comments about chemical versus physical, and hopefully you had a chance to look at this and think about it already, but let me review for a couple of things. So chemical and physical properties, we're going to break things up, and you can observe things that happen, and you'll want to know, is that a chemical change? Is that causing the object to change into a different chemical entity? Or is it a physical change? So I'm just changing like state or something. So when something freezes, that's going to be a physical change, right? If I freeze water, I still have water. It's just in a different state. But if I burn something, right now I've created charcoal and carbon dioxide and whatever, and that is a whole different substance, has different properties to it. So lots of physical properties are possible, right? So we can have the color, there's the color, the smell, the freezing point, all sorts of things. In chemistry, we'll get into very specific measurements. We'll get into light absorption or light reflection. And when we get back into the lab, hopefully soon, that we'll be able to do experiments and judge how well they absorb specific wavelengths of light. It's a very effective tool for chemists. So spectrophotometry, it's a great way that we'll get to do to interrogate and understand what compounds are and how they look. All sorts of things, so how well you can see through it. Chemical properties are going to be sort of how things behave under different sort of reactive conditions. So does it burn by itself? So if you put it with oxygen and give it a flame, does it burn? If you put it with different metals, how does it react? And we'll come up with a whole, hopefully we'll do a lab on an activity series, so we'll figure out how reactive things are to different metals. So some metals are way more reactive than other metals, and so you can classify a compound by, does it react with magnesium, and does it react with lead, and does it react with iron, and some of the behaviors that exist when it's adjacent to other things. And acid test. So if you're a geologist, you carry around with you a little bottle of acid. So it's one way you characterize rocks. You pull a rock up and you drop a couple drops of acid on it and see, does it fizz like limestone, or does it not fizz like granite, I think. So you can tell the properties, the chemical properties of something by how it reacts with something. And lastly, radioactivity. So how quickly does something decay, or does it decay? And we're going to get into this as our first unit, so we'll get into radioactivity, and you have some idea about how to determine that. So the challenge is that when you see a change, you have to figure out, is that due to some chemical property that's been exercised, and so now it's turned into a different object, or is it just changing state or something? So there are hints, and most of these are not definitive, right? So if you see bubbles, good chance that it's a chemical reaction that's happening, and you're getting a different substance out. But you can boil stuff and you'll get bubbles out of that. So you can't have bubbles just from heating, not necessarily from a chemical reaction, of course. Color changes are a little bit tricky. So some color changes are due to a change in pH. So a substance will change color, but it's still the same substance. Other times a color change is a really good indicator that there's been a chemical reaction that's happened. Temperature change is one of the better ones. So pretty much if you have something and the temperature either increases or it decreases, without you doing anything to it, right, then most likely that's going to be a chemical change. So of these, that's probably the strongest indication that you have a chemical reaction that's happened, and you'll be able to investigate that. And there are all sorts of other things like smells. So it's not too hard to synthesize the smell of bananas in a lab, right? It's not the same, not exactly the same chemical compound that you find in bananas, but it smells like them. So it's not too hard to make those. And so if you're sitting there in the lab and suddenly you start smelling bananas coming from your experiment, probably a chemical change. Or your lab partner has just cracked open a banana and has eaten it, which they shouldn't be doing in the lab, I guess. Anyway, I get you to think about these, so we'll get a chance to see these as we go through the year and look at different reactions. And I hope that helps. Bye.